So here, find all the zeros of this function by factoring. When you are told to factor something, the first thing you should try is a GCF factoring. In this case, there is a GCF of x to the fourth. So we have x squared minus 3x minus 28. You are finished factoring, just like if you're told to factor a number, you would stop factoring when you couldn't factor anymore. And it's the same with polynomials. Factor until you can't factor anymore. Once I take that GCF out, I've got this quadratic left. That quadratic still factors. So we've got x to the fourth times x minus 7 times x plus 4. So we have factored it. Now to find the zeros, we just set the whole thing equal to 0. In this case, we have 1, 2, 3 things all being multiplied by each other. So if any of those 3 things are 0, the whole thing would be 0. You could. Now what would make x to the fourth 0? 0. What would make x minus 7 0? 7. What would make x plus 4 0? Negative 4. Here, the first thing you want to try when I ask you to factor something is looking for a GCF. There is not a GCF in this case. This is also not a quadratic because it's not to the second power. But this polynomial is kind of like a quadratic because we have a constant term, and then this right here is x squared, and this is x to the fourth. So it has the same pattern that a quadratic would have, which would be x to the first and x squared. So this is quadratic-like, which means we could factor this. What two numbers multiply to negative 4 and add to negative 3? Negative 4 and 1. And if we just adjust this to, instead of being x minus 4 to being x squared minus 4, that is the factored form here. Anytime you have x to something and then that squared. So if this were like x cubed and x to the sixth, you could use this. Or if it were x to the fourth and x to the eighth, you could use this. So anytime those two powers are, like this one is twice that one, it's quadratic-like. And there's a constant at the end. At this point, we want to set this, well, we can factor more. G of x is x plus 2 times x minus 2 times x squared plus 1. The difference of two squares factoring. We've got 3 things. 1, 2, 3. X could be negative 2. X could be positive 2. The last part is going to be a little bit different. X squared plus 1 could be 0, which means x squared could be negative 1. When you take a square root to solve an equation, what do you have to do? Square root both sides and include a plus or minus, which means x could be I or x could be negative I. You could say plus or minus I, that's the same thing as I or negative I. Here, in these two examples, this one is x squared. This one is x to the fourth. So this one has a 0 of 0 with a multiplicity of what? So this one has a 0 of 0 with a multiplicity of 2. This has the same 0 with a multiplicity of 4. So graphically, what do you see as a difference here? Now, this one. This is x cubed. This is x to the fifth. Again, x cubed is one that I would assume a lot of us are familiar with. The graph looks like that. It's only hitting the x-axis at 0. Same thing with x to the fifth. It's only hitting the x-axis at 0, but you can see as the multiplicity increases, that section of the graph right here flattens. Okay, we can zoom in on that a little bit more. So, if the 0 is flatter, that means it's got a higher multiplicity. So here, we're going to have zeros, and we're going to list their multiplicity. If you look at the graph, there's a 0 at -1, there's a 0 at 2, there's a 0 at 4. The multiplicity of the 0 at -1 is 2. And I know that because it looks like a little parabola touching at -1, and it's not particularly flattened, so I wouldn't say it's 4. The multiplicity would be 2. The 0 at 2 has that shape of like x cubed, but it's a lot flatter, so I would say that multiplicity is 5. And then the 0 at 4, anytime the graph just passes through, that's got a multiplicity of 1. Okay, to have higher multiplicities, identify zeros and their multiplicities. Here we're told what the zeros are, we're told what the multiplicities are, and we're asked to write the function in general form. So, algebraically, if I have a 0 of x equals 0, I could say that I'm just going to have x, and with a multiplicity of 2, the exponent's 2. If I have a 0 of 3, I would multiply all of that by x minus 3. That has a multiplicity of 2. So to get this in general form, I just have to multiply everything out. Like this. Then we've got x to the 4th minus 6x cubed plus 9x squared.